Hello, it's Keith here, and this is lesson 23 of the Suck Hunt series of Z80 programming tutorials. Today we're looking at the amazing introduction you can see here. I'm not sure that's entirely an accurate statement, but the at least moderately acceptable introduction. We're going to have a look at that. We're going to have a look at the palette switching routines, and basically that will get us through most of the code that we need to look at of this version of the game. Okay, well, let's go over to the source code and let's just take a look. Okay, so the introduction routine, well, again, like the main graphics, of course, it's done with tilemaps. Really, everything's done with tilemaps on the master system, but this was done with tilemaps in all cases. The graphics are miniature tilemaps, and that's to try and reduce the amount of memory they take. If I'd stored them as bitmaps, any duplication would have been wasted, and so by using tilemaps, we can cut down the duplication. And as I said last time, they're actually 8x4 and the lines are doubled up. So if you look at them closely, you'll notice that the pixels are kind of rectangular almost vertically. And that's just again to save memory, because on the CPC, this game fitted within 48k of RAM. So that's why we're doing that. You can see the format of the tilemaps here. Here are the tilemaps. Again, as I said before, 1 byte if it's under 255 tile. If it's over 255 tiles, 2 bytes. Now, each stage of the introduction has 2 frames of animation. You can see it's running again here. You can see there's 2 frames in each corner, and there's 4 corners in total, and they're different colors. And you can see that represented here in the intro animation list. So you can see here, that's the first stage of animation. That's an XY coordinate and a color number in the first line, and then the 2 pointers below that are pointers to the tilemaps. So that's the first corner. The second corner is incorrectly marked 3, the third corner is incorrectly marked 2, and the fourth corner is correctly marked 4. So that's the animations there. I got them in the wrong order when I drew them, what can I say? So anyway, that's the introduction animation data. Now, when it comes to the actual execution of the introduction, where is it? Here it is. So the first thing we're doing here is we are fading out to black, and then we are turning the music off. And that's because we don't want the interrupt handler to be trying to play any music while we're getting our data transferred. We're then transferring the bitmap data using define sprite double height. Now, this is a modified version of the code we looked at last time. It just basically reads in 2 bytes for the 2-bit planes, but then it doubles them up so that the 2 consecutive lines contain the same byte data. We're then loading up the Arcos tracker song for the introduction here. We just transfer it to the RAM address that Arcos tracker is playing from, and the interrupt handler will play it. We've got our introduction animation count. There's 4 different corners, so 4, and the pointer there is being loaded into IX. What we then do is we are going to show the next stage of the animation. So we're loading in here the X and Y position that the animation is going to show at. We're also loading in the address of the tilemap here. So that's the tilemap address. And then what we're going to do is we're going to use this show tilemap alt pos quarter intro. That's for the introduction. It shows a quarter screen tilemap at the X and Y address specified. Now the screen is currently black, so what we're then doing is we're loading in A with the palette number, and we're using do pal fade in, which will fade in the color specified in the accumulator. We then pause a while, load in the second address of the tilemap, show the second tilemap, the screen is still visible, and then we wait again, and then we fade out in the color again specified by A. We're then moving to the next definition within the introduction animation, and we're jumping back up here, and we're repeating for the other 3 iterations of that animation. Now, once we've shown the introduction animation, we're then showing the title screen. So what we're doing here is we are loading in the 2 tile maps and sending them to the 2 caches. This is to create the 3D effect. There's 2 tile maps. I've got the 3D effect disabled because it's a horrendous epilepsy warning. So we've got that disabled, but there are 2 tile maps that are slightly different to give the 3D effect. So we're loading those both directly into the caches here, just dumping them straight to the cache there, because we don't, the 3D effect is pre-calculated. It's not being done by the software that calculates from a 3D depth. Then what we're doing here is we are loading in the tilemap data. This is the title graphics for the 2 tilemaps. Now here is the data here. You can see I had to do a ton of optimization to get this to work. Basically, if I go through these, you can see that these are the 2 frames and they're slightly different. That gives the 3D effect, but you'll notice there's various glitches here, like that 3D has a bit of a shadow. That's a bit blocky, there's pixels missing, and the reason for that is I had to get this down to a number of tiles that would fit within VRAM. This is, I think, basically the entire limit. I think maybe there was one tile spare at the end, so it was a ton of work to get 2 full screen images with the 3D effect with the graphics that I wanted, and unfortunately it meant no room left for the font, so I can't show the score on the title screen. Anyway, we're transferring that data to VRAM here. We're using the same define sprite routine because again it's 4 color data. The 3D effect only uses 4 colors. And then what we're doing here is if the accumulator is set, we're going to play the speech. Now the speech is done by ChibiWave, which I covered before in the platform specific series. It plays a wave file. There is a problem though. We need to disable interrupts for it to work correctly, and that will cause us color problems. So we're disabling interrupts, and then we're loading a black and white palette in just for while the speech is playing, and then we're going to restore our proper palette later on. We'll actually do that when the interrupts re-enable, because the palette will be reset from the correct one for the current 3D setting. Now the accumulator will decide whether the speech is played, and the accumulator will be 1 if we've just shown the introduction, but if it was a game over, the accumulator will be 0, because we won't want to play the introduction unless we've shown the Operation Wolf parody, because it says Operation Suck because it's a parody of Operation Wolf. Now when it comes to setting the palettes, there's going to be 2 times we're going to want to set the palettes. Either because the player has toggled the 3D settings, and that will use this set palette function here, and we will be using a palette number, a numbered palette effectively, and this will need to set the interrupt handler to change the palettes for the left and right eye. Now in 3D mode with shutter glasses they're both grey, but in the other ones it will be red and blue or green and magenta and so on. So that's what we're doing. Now the other thing is, of course, during the introduction sequence we're going to be using the coloured palettes for the fade. So the way we're doing things is basically we're getting the palette number and we're effectively multiplying this by 4, and then we're loading a set of pointers from the palette list, and then we are reading in those 2 pointers. We're loading one in here and that's the left eye colours, and we're loading the other in here and that's the right eye colours, and that's what we're going to do. Now we've got a special one for black here, that's just to black out the screen, and then we've got the version for fading. So we've got the fade in version here, and we're going to load in pink and blue here, either for fading in or fading out, and then depending on the accumulator we're going to potentially swap those over. And if the accumulator's 1, then we're going to fade in blue, but if the accumulator's 0, then we're going to fade in pink. Now this uses this set palette function here, which will just jump in here and load in a single palette pointer and set both eyes to that palette. Now the palette pointers basically here are a set of pointers to a set of palettes, so you can see some of them there, and the palettes are of course in Sega Master System format, which is 1 byte per color, so that's all black here. You can see here we've got some dark pink here, and they'll get gradually brighter according to the stage of the fades. Now when it comes to the 3D palettes, of course, we've got our palette here for our anaglyph glasses, our red cyan. We've got our grey palette here for the shutter glasses. We've got the color code one here, and then we've got the green magenta one here. So we've got the various palette options here, and then which ones to use for the eyes here are defined in this list here. Now of course the 3D mode with the shutter glasses and the 2D mode both share the grey one here, so we managed to save a little bit of memory by using the same palette there for both. Anyway, that's all we're going to be covering today. Now next time we're going to be going over the last part of the code. We're going to be looking at the title screen code, the code that handles the input, and the main game code that handles the actual gameplay that's specific to this system. The multi-platform code is common to all of them, so we're not going to cover that. Anyway, hope you found this interesting. If you have, go to the website, download the source code, download the finished game, have fun with the game if you want, have fun with the source code if you want, and as I say, if you manage to use the source code in some way in your own projects, even if they're commercial, you're welcome to do so. If you want to support my content, you can buy my book, Learn Multi-Platform Assembly with Chibi Akamas. It covers Z80, 6502, 68000, 886 and ARM. It's available for Amazon now. You can also back me on Patreon if you want. Anyway, I hope you've enjoyed this. Thanks for watching today, and goodbye.